The title of this project is The Effects of Prescribed Fire Timing on Native Plant Composition, Forage Biomass Accumulation, and Root Carbohydrate Reserves in the Kansas Flint Hills. This is a 6-year project, and from here I'm going to present the first 2 years of data. Many ranchers in the Kansas Flint Hills practice annual spring season prescribed fire. Unfortunately, fire applied during this time of year may actually stimulate the proliferation of the invasive form Sericea lespedeza. Recent work out of our lab determined that shifting the timing of prescribed fire from April to August or September achieved control of Sericea lespedeza without causing negative changes to native grasses or forbs. Therefore, the objective of this study was to document the effects of prescribed fire timing on forage biomass accumulation, native plant composition, and root carbohydrate concentrations in key tallgrass plant species. 18 pastures were grouped by watershed and randomly assigned to one of 3 prescribed fire treatments that you can see pictured here. Spring burn pastures are outlined in blue, summer burn pastures are outlined in purple, and fall burn pastures are outlined in green. Average burn dates were April 7th, August 21st, and October 2nd for the spring, summer, and fall prescribed fire treatments respectively. Basal plant cover was measured annually using a modified step point technique. Forage biomass was estimated in 2018 and 2020, and root carbohydrate concentrations in big blue stem, little blue stem, Indian grass, and purple prairie clover were evaluated annually. Looking at the effects of prescribed fire timing on plant species composition, basal cover of total grasses, C4 grasses, total forbs, and total shrubs did not differ between prescribed fire treatments. However, basal cover of native grass species was greatest in the summer prescribed fire treatment, intermediate in the spring, and least in the fall prescribed fire treatment. Looking at the effects of prescribed fire timing on forage biomass and root starch concentrations, forage biomass accumulation did not differ between the 3 prescribed fire treatments. In addition, root starch concentrations of big blue stem, little blue stem, Indian grass, and purple prairie clover were not different between the 3 prescribed fire treatments. Overall conclusions from this study were that forage biomass accumulation did not differ between prescribed fire treatments. Prescribed fire timing was associated with minor changes in rangeland plant composition. However, root starch reserves in key tallgrass plant species were not affected by prescribed fire timing.